Hi, this is the third video for the limit concept here in this course of differential calculus. And here I have a nice graph here that it's a piecewise function. I'm just not going to write the statement for the piecewise function, just going to say work to this graph here, and I'm going to ask here several questions and we'll be answering to the graph here. Here I'm going to start with these statements here and trying to find out what it would be here in the graph here. So let's start with this one. Limit when x approaches to 2 from the left for f of x. We have to locate here the number 2, and let's say from the left of 2, if we get closer and closer for the left of 2, we will be getting closer and closer here to this part here, which is, okay, we are not touching this number because it's not included here. It just would be just the same. It would be inputting something like 1.999, something really close to 2, but it's not actually number 2. But the thing is, we'll be getting closer and closer to a value, which would be here the number 2. So I'm going to write it in here. Here, the number 2. Now, let's get to the second one, to this one here. What's the limit when x approaches to 2 from the right for f of x? Now, it will be here again, but now we are approaching from here, from the right. Let's say we'll be placing here a value of 2.001 here. And that is to say that instead of getting through here, we'll be getting actually through here. You can see the values from the right are getting from here to here, the right of 2. You will see here through a line here. Sorry, this is a very ugly line. Well, if you see through a line from the right to this point, you will be getting from here to here. So the value of the limit from when x approaches 2 from the right, it's actually the number 5 here. And I'm going to write it in here, the number 5. Now that we have this limit from the left and from the right, we can therefore conclude that as they have different values here, then the limit when x approaches to 2 for f of x doesn't exist. They must have the same value in order for a limit to exist. Now, I'm going to add here another question here, just right here. What is the value for f of 2? The value for f of 2 will be, what is the value here? And well, you can see that the value here is excluded, and actually it's included in here. So the value for f of 2 would be a 5 here. I'm going to write it in here. And I want to notice something here. There is the limit. The limit doesn't exist here because the limit from the left and from the right are different, but it doesn't imply that it wouldn't have a value here. There is a value for f of 2, just there is no limit for f of 2. Now, I'm going to move here to this one here. What is the limit when x approaches to 4 from the left here? Now, from the left to 4, the 4 is in here, would be, if I would be getting here for 4, I'll be getting to this point here, which is actually the number 3. So the limit from x approaches from the left is the number 3. Now, I'm going to proceed with this question here. What's the limit when x approaches to 4 from the right? For the right would be the values of 4 from the right. We'll get from here to here, which is actually, again, the number 3. And now that we have both limits from the left and from the right, we can therefore conclude that the limit when x approaches to 4 for f of x would be the number 3. We are getting to the same value here, and therefore the limit exists. Now, notice something here. I'm going to ask the same question then here. What would be the value for f of 4 here? As you can see here, this value is placed up here, not in here. It's displaced, it's removed from the actual line or trajectory here and displaced through here. So the value for f of 4 is different from the limit. The value for f of 4 would be actually here in the 4. So f of 4 is equal to 4. So we got here to another case here. We do have a limit here, which is equal to 3. but the value for f is different than that one. Now, I'm going to ask here some other questions with here. What's the limit when x approaches to 0 from the left for f of x? That is to say, we're getting here to the 0 here. And following the graph here, we can get from the left of the 0, we get here to the number 1. Just here, number 1. Now, I'm going to ask this question here, just limit when x approaches to 0 from the right, would be from the right to the 0 here, and we can just follow the graph here. We get actually to the same point 1 here, the same point 1. Now, we got here the limit from the left and from the right. Now, therefore, we can conclude that as they are the same, they have the same value, the limit when x approaches to 0 will be a1. Now I'm going to ask the same questions in the previous two cases. What is the value for f of 0 here? F of 0, as you can see here to the graph, will be here the number 1. And here we go to a different case, because in here the limit has the same value that the actual function in this when x approaches to 0. And this is actually this is actually a new concept here that we'll introduce here just for today, for this video here. This is in mathematics. I'm pretty sure you will infer why. This is in mathematics, these cases, what is called the concept of continuity in mathematics. And I'm sure you can just see it here on the graph here. When the limit has the same value that the function, you have continuous. You are continuing with the graph here. When the limit doesn't exist, even though you have a value for the function, there is no continuity. You have here this big jump you have to do from here to here in order to continue to the graph here. You have to jump here. And when you have a limit here, that you have a limit that exists, but the value of the function is displaced, is removed from here to some other place like here, then this is discontinuous. This is discontinuous, and it is not something like this here. So I'm just going to write in the center. I already have it written here, the concept of continuity in mathematics. And here, that is it. When the limit, when the x approaches to a for f x equal to L, and the actual value of the function in a is equal to L as well, that is the concept of continuity in mathematics. But I think you can pretty much see it here on the graph. When you have to jump from one point to another one, or when you have a hole here, that is a discontinuity. Now, there is another case for discontinuity. I'm just going to save that for another video here, just to make clear, just another video when we will get more into the concept of continuity. For this video, that will be all.